Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Zikri bin Midain. My supervisor name is Tuan Syed Kushairi bin Syed Nordin. Today I want to present about my bachelor degree project. The title is Portable Refrigerator by using PELTIER as cooling medium. The table of contents. 1. Introduction. 2. Problem statement. 3. Objective and scope of research. 4. Literature review. 5. Methodology. 6. Result and analysis. 7. Conclusion. And last, 8. Recommendation. This is the introduction of this project. Refrigeration is a process to remove the heat from cold side to hot medium. The word of heat transfer is the mechanical word. Thermoelectric device provides a promising alternative refrigerator system because of the mechanical device that is overwhelming loads of electricity and adverse impact to the environment. In this study, a portable refrigerator is designed by using Peltier device. Peltier elements combined with fans and heat sinks on both sides installed to the refrigerator box. Problem statement. The Peltier module's hot side is the primary problem. The thermal equilibrium concept is used by the hot side of the Peltier module with the cold side of the Peltier module, which affects the cooling temperature of the small refrigerator. A refrigerator with a Peltier module, on the other hand, has a low cooling temperature. By using only one Peltier, refrigeration of the portable refrigerator cannot reach the required cooling temperature. This will affect the drinks that will be stored in the refrigerator. There are two research objectives in this research. First, to design and construct a portable thermoelectric refrigerator using a Peltier module. Second, to predict the value of a dependent variable, which is temperature, based on the value of an independent variable, which is time. And for the scope of research, this project aimed to design a portable thermoelectric refrigerator that uses a Peltier module and predict the value of a dependent variable based on the value of an independent variable. The result calculated using a statistical method, simple linear regression. Design the project as well to get the ideal temperature of the smart portable refrigerator using Peltier module. There are many research that I found in this project. This is for example, for this literature review that I will explain. From Ibanez Pui 2017, a TCHU thermoelectric cooling heating unit is a cutting-edge technology that uses thermoelectric phenomena to heat and cooling a building. From Virus Rimoli 2020, the Peltier thermoelectric cell was sandwiched between two heat sinks and one exterior and the other side the cooler box which remove heat. From Huang 2000, the thermoelectric module's performance curve, which was acquired experimentally, is utilized in the design computation. From Zebajadi 2015, thermoelectric cooler or Peltier coolers pump heat in the opposite direction of normal heat flow. This is the methodology of this project. First, we connect to the power supply. After that, the current will flow to both outside fan, and the current also will flow to both inside fan, and the current will flow to thermometer, and lastly the current will flow to the Peltier device. This is the diagram concept for this project. There are two figures in this slide. From the left is portable refrigerator simulation design that I designed using SketchUp 2020. And for the right, this is the prototype of the portable refrigerator that I designed. Okay, for the result and analysis. Model 1 is heatsink temperature. We can see the graph is the temperature decrease when the time increase. For this project, the simple linear regression equation, we can see that y is equal to 21.93 minus 0.1125x. The r square is 0.3709. That means 37.09% of the variability in temperature is explained by the regression of temperature on time. On another 62.91% of the temperature is due to other factors. P-value or significant F is equal to 0.02717. This is less than 0.05. That means is the model is good and can be accepted. Second model is the temperature in the foam box. We can see in the graph the temperature is decreased when the time increase. The simple linear regression equation is y equal to 29.144 minus 0.1758x. For the r square equal to 0.9302. That means 93.02% of the variability in temperature is explained by the regression of temperature on time. Another 6.98% of the temperature is due to other factors. P-value equal to 0.00. It means it's less than 0.052. This model can be accepted. Third model is temperature of the water in the bottle inside the foam box. Okay, we can see the temperature versus time graph. It's also the temperature decrease when the time in minute is increased. The simple linear regression equation is equal to y equal 29.505 minus 0.1381x. Okay, for the r square equal to 0.9809. That means 98.09% of the variability in temperature is explained by the regression of temperature on time. Another 1.91% of the temperature is also due to other factors. Okay, for the p-value equal to 0.0000, less than 0.052, and the model is good and it can be accepted. The conclusion for this project. Firstly, There's the effect of ambient temperature, which is one of the variables that influence the temperature of the Peltier module and the foam boards. If the environment is cold, the heatsink will absorb both the cold from the environment and the heat from the Peltier module's hot sides. This will aid in the efficient dissipation of heat to the surroundings and the reduction of the hot side's temperature. The independent or independent variables of the Model 1 is temperature, heatsink, and time. Model 2 is temperature, foam boards, and time. And Model 3 is temperature, water, and time. From these three models, the highest R-square result is Model 3, which is 0.9809. The coefficient value 0.1758 from Model 2 is the highest value compared to Model 1 and Model 3. This means Model 2 has a greater impact or effect than the others. There are two improvements and recommendations for this project feature work. First, to improve the system and lower the temperature of the portable refrigerator. Another recommendation is to use an active cooling heatsink to remove external heat from the Peltier module. One way that can be used as an example is to make the water flow on the hot heatsink so that it cools faster on the outside heatsink.
This is the video that I ran my prototype.
Thank you for watching my video.